Here we go. Absolute value inequalities. Although they are kind of similar to absolute value equations in terms of you've got to get the absolute value by itself first, you've got two different scenarios to worry about. You've got to worry about if the absolute value is less than or if it's greater than, because it gives you two totally different scenarios. Remember, the absolute value measures distance, okay? And so when it asks you for the absolute value or the distance to be less than something, this is creating a restriction, okay? It's creating boundaries. So it says that your distance has to be less than some kind of value. It's just like whenever I take my dog on a walk and she's on a leash. She is free to go wherever she wants to as long as she stays within 6 feet of me. That's the length of the leash, right? So her distance from me has to be less than 6. So where can she stay? Here she is right here. She's in between plus or minus 6, or plus or minus whatever that value is, right? That's where she can be. So this absolute value inequality gives you an AND statement here for compound inequalities, which we know means an intersection, right? As opposed to this one where it says, I want the distance to be more than so many units away. Instead of keeping things restricted and close by, this is saying stay away from me, right? And especially now with all of the social distancing, these are the inequalities that we're talking about. Whenever I'm around people that's not my own family, I want your distance to be more than 10 feet, right? How close can you be? You can be within 10 feet on either side of me, but don't come any closer. I want you to stay away. So where can these other people be around me? They can be more than, say, 10 units, or they can be less than 10 units on the other side, meaning less than negative 10 on the left side if you looked at this on a number line, which is what we're going to do. So distance being less than, stay close by. Distance being greater than, stay away from me. Let's take a look at this first example here. The absolute value of x is less than or equal to 6. Well, let me scroll back up here. This is the first scenario. I want your distance to be within 6 units. So if I apply this, and you've got this intersection here, which can instantly go to this 3-part inequality, I can do that here. Where will my solutions be? Well, I know that x is going to have to be on the left side of 6, while at the same time being greater than negative 6. So you're putting x in between. You're creating these nice, well-defined boundaries for your solution set, which says you can go as far to the right as 6 or as far to the left as negative 6, but you got to stay within that region. And when you think about what that looks like as a picture, here's 0. You can see this as being me, right? If I want your distance to be less than 6, like my dog, you can go as far out to the right as 6. You can go as far out to the left as negative 6. But you have to stay within, because I'm restricting your distance. Now I have or equal to, so that means these guys get to be filled in, just like this. And then we describe this using interval notation. So from bracket negative 6 to positive 6. That's what this absolute value inequality is saying. All right. In this next piece, we have the absolute values greater than 10. Again, it's that same scenario that I was telling you about. I want your distance from me to be more than 10. Don't come any closer than that. So, according to the statements we had at the top of this page, that means that you, the solutions here, you can be to the right of 10, or, watch this, keep this the same, change the direction, change the sign like that. So that means you've got to stay away. Stay away where? Well, greater than 10, so to the right of 10, or to the left of negative 10. And you think about this on the number line. Again, here I am. I don't really want to be around people. No offense. So here is 10. And here is negative 10. Where can you be? You can be to the right of 10. You can be to the left of its opposite, negative 10. That's where you can stay, because I need a 10-foot buffer on either side. 10 feet over here, 10 feet over there. So where can you stay? You can be anywhere in this region from negative infinity to negative 10, union, or from 10 to infinity. So, I want you to notice something in the last example. Let's go back up here for a second. I went ahead and instantly I wrote this. I wrote that three-part inequality because to me it makes the most sense for understanding where can you be. You've got to be in between negative 6 and 6, right? If I apply the statement that's up above here, this is me saying that x is less than or equal to 6, and, which means intersection, x, change the direction here to be greater than or equal to, change the sign to be negative 6. And by changing the direction, changing the sign, that's the same thing that I'm doing down here with this absolute value being greater than. But there's a difference. Here this is and, which means intersection. Down here this is or, which means union. So in order for this to work, you've got to be less than 6 and at the same time greater than or equal to negative 6, which is this region in between. But instead of me writing this, that's really the better way to write that. As a three-part inequality, it's a lot easier to solve. Now, unfortunately, I can't do a three-part inequality down here. And some students are going to do this, and they won't listen to me. So let me go ahead and say, what I'm about to show you is wrong. So here is what students do that just drives me crazy. And this is an easy way for students to lose points. They say, oh, I'm just going to make this a three-part inequality like I did the other one. I mean, what's the big deal, Mr. Craig? So they do this. Right? Admired by their friends all over social media. Until they pause and think about what they've just said. They've just stated that negative 10 is greater than 10. And that, my friends, is very wrong. So don't say that. If you say it here, that's wrong, you lose points. I don't even care if you get the right answer, you're still going to lose points. You don't ever tell me something like this. Up above, it made sense because negative 6 is less than or equal to 6. So let's do a couple of examples so you can see the differences between these two and know when you can write a three-part inequality and when you need to separate into your two separate inequalities to have the two sections on the number line.